All right, so today we're gonna start the unit on volume and surface area, and we're gonna start with 9.1. To start off, before we get into like three-dimensional shapes, we're gonna just review two-dimensional shapes. You've probably all seen these before in previous math classes, but it's good to get a refresher on area and perimeter a little bit, just so that when we get into more complicated types of formulas, you know the basics of this. So hopefully you've seen all of these formulas before. If not, take a minute to go over them. We're just going to apply these using the diagrams that are given to us and then finding out what the area is. Like for number 1, we have a square, and now we can find the area of it because the formula for area of a square is just side squared. So the side is 8.5, so I would say 8.5 squared, and that is what my area is going to be. You can just type that into your calculator, and that comes out as 72.25. And don't forget about the units, because whenever we're finding area, there's measurements to it, and so it says this is being measured in feet, so we want to include feet squared. Whenever we're finding area, we should include that little 2, just because we measure area in square units, like square feet or square inches. So this would be our answer. Number 2, we have a triangle, and the formula for an area of a triangle is right here. It is 1/2 times the base times the height. So here we can see that the base is 15 and the height is 21.3. So we would just plug in those numbers into the formula using parentheses. So 15 is the base, that's going to go in parentheses, and then the height is 21.3, that's going to go in parentheses. Then you would just type all of that into your calculator and find out what that comes out to. It should be 159.75 meters squared. So that is the answer there. Number 3 is what we would call a parallelogram. It's kind of like a rectangle, but it has a little bit of a slant to it, and so it's called a parallelogram because these sides are parallel to each other, and then these sides are parallel to each other. And the formula for that is right here. The formula is just base times height. So the base would be 12.9 and the height is 7.1. So to find the area, we just have to multiply those together. 12.9 times 7.1, that comes out to be 91.59. And then we're going to say inches squared because those are our units that we can see there. Number 4 is a circle, and to find the area of a circle, the formula is right here. It's pi r squared. So r stands for radius, and then the d stands for diameter. Hopefully you remember hearing those words from previous math classes. Diameter is all the way across, and then the radius is just halfway across. So because we want the radius, we just need to take 26 divided by 2, which would be 13. So that's the value we're going to use to plug in for r. So we're going to say pi 13 squared. And then to find the area, you can just type that into your calculator. There's a button for pi. Instead of having to type in 3.14, the more exact answer would be just typing the button for pi, and I can show you how to access that in the calculator. Then parentheses 13 squared, that comes out to 530.93. And this time our units are yards squared. Okay, number 15 might look like number 5, might look like number 3, but it's actually more of a trapezoid, which would be this one. So that means in a trapezoid, we have 2 bases of different lengths, and then we have a height to it. So this is what we can see in number 5. Here's a base, and here's another base, and then the 16 is our height. Sometimes they'll throw in extra information just to throw you off, like the 16.5 and the 21. We don't need to know that because it's not part of the formula. If we wanted to find the perimeter, then that would be helpful, but right now we're just finding area, so we're only going to use the 19, the 16, and the 27, because this is our formula. It's A is equal to 1/2 times the height. Well, the height is 16. I'll put that in parentheses just to separate it. And then in parentheses, we want to add the bases. So base 1 plus base 2. So I'm going to say 19 plus 27 in the parentheses. So when you go to your calculator, you would just type all that in with the parentheses 1/2, parentheses 16, parentheses 19 plus 27. And that should come out to 368. And we have centimeters squared. Number 6 is just a rectangle, and rectangle is really easy. Maybe you remember that the area for rectangle is length times width. And so we just multiply these sides together. The area is just going to be 3.7 times 10.5. And you can just type that into your calculator and get your answer. It's going to be 38.85 kilometers squared. Next, let's look at number 7. This is a triangle, and they needed to include this 14 over on the side because that's the height of the triangle. The height has to be perpendicular to the base, or creating a 90-degree angle with the base. And so if you know like this distance, that's not the height. That's kind of just there to distract us. What we're going to use is the 14 and the 29.5 to plug into our area, our formula for area of a triangle. So it's 1/2 base times height. Our base is 29.5 and our height is 14. So don't get confused by the 37.2. That's like extra information. So go ahead and type that into your calculator and it'll come out to be 206.5 inches squared. Okay, let's look at number 8. This is also a parallelogram, and the formula for area of a parallelogram is base times height, remember? So that's why we see this 16.1. That is our height because the height has to be perpendicular to the base, and we can see it's creating a 90-degree angle with this base, 11.8. So the 18.5 in this case is just kind of there to distract us. We don't need to use that. What we're going to end up doing is 16.1 times 11.8. And then when you type that into your calculator, do the multiplication, it comes out to 189.98 meters squared. So this is our answer. Okay, number 9 is a half circle or a semicircle. And so what we can do is just use the formula for area of a circle and multiply that by a half. So that way we just get half of that area. So I'm going to put half pi r squared. Pi, and then my radius is 17, and I'm going to square that. So it's just going to be something that you would type into the calculator, 1/2 times pi, parentheses 17 squared. And this comes out to 453.96, and our units are feet squared. Okay, so number 10 is a trapezoid, and so we're going to have to use that formula for the area. The formula for area of a trapezoid is 1/2 times height, and then base 1 plus base 2. So let's go ahead and find out what is our height. Well, the height has to be perpendicular to the bases. So it would be this one because this is the one that creates a right angle with the bases. The 9 is not really the height, it's just the length of this side. So that's just there to distract us. Maybe you can cross it out so you can know that we're just going to use these. In this case, the 7 and the 13 are the bases. The way that you know what are the bases have to be parallel to each other. And so because those sides are parallel to each other, those are our bases rather than the 9 and the 5. So I'm going to say 1/2 times height, which is 5. And then in parentheses, let's add the bases. So 7 plus 13. Then go ahead and type that into your calculator. We would have 50 millimeters squared. And let's go ahead and flip to the next page. We just have a few more examples before getting into the word problems. So number 11 is a triangle. And the thing about this triangle is that we're going to have to use the formula area equals 1/2 times base times height, right? But this is the base, the 7, and the 18.2, that's not the height because the height has to be perpendicular to the base. And we don't know what this side is. That would be our height. And so we need to do a little bit of math to figure out what this height is. And to find that, so what we're going to need to use in order to find this x is Pythagorean theorem, the formula that we learned about in the last unit. It's this one, a squared plus b squared equals c squared. This is a very important formula that you shouldn't forget because we're still going to be using it throughout this unit as well. So what we can say is that 7 squared plus x squared, our legs, equals the hypotenuse, which is 18.2 squared. So in order to solve this, you could find out what 7 squared is, which would be 49. And then you could also find out what 18.2 squared is, which is 331.24. Then you can subtract this 49. So x squared is equal to, when we subtract, we end up with 282.24. And to find out what x is, just take the square root of that. So x is equal to 16.8. So that's what we're going to write in as our height. And now we can find the area, because the area is 1/2 times the base, which is 7, times the height, which is 16.8. Then we would type that into our calculator and find out what the area is. It comes out to be 58.8 feet squared. So there's just one extra step that we had to do there, which was to use Pythagorean theorem. Okay, number 12 is a trapezoid, and let's see if we can identify the bases. The bases have to be parallel to each other, so it would be the 19 and the 7. The problem with the 10s, these are not perpendicular to our bases, right? They don't make a right angle. We would need to know what this length is, and because that would make a right angle with our base. So we're going to have to figure out a method to find out that height, and it's going to include the Pythagorean theorem again, because let's say that we know that this whole top is 19 and the bottom is 7. So if I subtract those, that should give me these lengths. So 19 minus 7 is 12. So that means that this side and this side is 12 together, and one of them each would be 6. And now I kind of have a right triangle because right there. And what I want to know is the height. So I can say 6 squared plus h squared equals 10 squared. 6 squared is 36. 10 squared is 100. And then subtract this. H squared is going to be equal to 64. And then you take the square root of that. The height is going to be 8. So now we can use the formula for area of a trapezoid. The height is 8, and then base 1 plus base 2, so 19 plus 7. And then just go ahead and type that into the calculator, and that'll give you your area. It's going to be 104 centimeters squared. Okay, so the next couple of problems are kind of like word problems. They require you to find a missing length. They might tell you the area, and you have to find out either the base or the height or a length or width, something like that. So like number 13 says a triangle with an area of 45.5 centimeters squared has a base that measures 14 centimeters. Find the height of the triangle. So it might help to write out the formula for whatever shape that we're talking about. We're talking about area of a triangle. And we can plug stuff in. Like we know that the area is 45.5. And we also know the base is 14. But we don't know what the height is. So we can just leave that as h. And then we would treat this like an algebra problem where we have to solve for h. So we would kind of simplify it. 1/2 times 14 is just 7, so we would have 7h. And then to get h by itself, we just have to divide by 7. So the height is equal to whatever 45.5 divided by 7 is, which is 6.5 centimeters. And that's our answer. So it's kind of doing the same thing that we were just doing, but kind of in reverse. We have to solve for a variable. Number 14 says a parallelogram with an area of 160.5 inches squared has a height that measures 7.5 inches. Find the length of the base. So remember that the formula for area of a parallelogram is you just multiply base times height, and that gives you the area. So we know that the area is 160.5, and we know the height, that's 7.5, but we don't know the base. So all we need to do is divide by the 7.5, and that's going to give us the base. The base would be 21.4 inches. And we don't need to write inches squared or centimeters squared when we're looking for just one of the measurements. We only need to put the squared if we're talking about the area. Number 15 says a trapezoid with base measures of 23 and 29 kilometers has an area of 390 kilometers squared. Find the height of the trapezoid. So I think it might help to remember the formula for area of a trapezoid. We basically have 1/2 times height times base 1 plus base 2. We know the area is 390. We don't know the height, but we do know the two bases. So we can say 23 plus 29. So what we're going to need to do is simplify this as much as we can. So like for example, we can do the addition in the parentheses, 23 plus 29, that comes out to be 52. And then we can also multiply these things together. 1/2 times 52 would be 26. So we would have 390 is equal to 26h, and then we just have to divide by 26 to find out what h is. 390 divided by 26 is 15. So our units are kilometers, so let's write that in as well. Okay, number 16 says find the length of the second base of a trapezoid with one base measuring 12 feet, a height of 4 feet, and an area of 58 square feet. So it's kind of the same formula. I'm not going to rewrite it, but I'll just follow this over here. Our area is 58. We know that the height is 4, so I'm going to plug in 4 for h. And then we know one of the bases. One of them is 12, but we don't know the other one. So I'll just put plus b. Okay, so what we can do is simplify, like 1/2 times 4. That comes out to be 2. So we have 2 parentheses 12 plus b. And then at this point, we have a choice whether we want to distribute the 2, or we can just kind of think about, well, the 2 is being multiplied by everything in the parentheses. And if we want to undo that, we can just divide to cancel out the 2. So 58 divided by 2 would be 29. And then on the other side, now we're just left with 12 plus b. To find out what b is, just subtract this 12. So b is equal to whatever 29 minus 12 is, which would be 17. And we're talking in terms of feet, so this becomes our answer for the second base. Number 17 says to find the diameter of a circle with an area of 380.13 meters squared. So remember the formula for area of a circle. It's pi r squared. we know the area is 380.13. We can write pi. And we don't know the radius, so let's just leave that as r squared. We can divide this by pi. And when we do that, we end up with 121, and that's equal to r squared. Then we can take the square root of that, and that'll give us our r. The square root of 121 is 11, and the diameter is just double the radius. So 11 times 2, that's 22, and we're talking in terms of meters, so the diameter is 22 meters. Let's talk about 18. It says find the perimeter of a square with an area of 361 square feet. So remember, the area for a square is just side squared. So because the area is 361, to find the side, you just have to take the square root of that. The side is going to be 19. And perimeter of a square, you just take the sides and multiply it times 4. So we would have 4 times 19. That is going to be 76 and feet. We only need the squared when we're finding area. For perimeter, you don't need to include that little part. And then the last one, which is just a word problem. It says, Mr. Payton would like to paint his deck. The dimensions of the deck are shown below. If 1 can of paint covers 72 square feet, how many cans will he need to purchase for 2 coats of paint? So because we want to coat this whole deck with paint, we need to figure out what the area is first. So the area of a trapezoid is 1/2 times height times base 1 plus base 2. Let's plug in what we know. We know that the height is 16.5 right here. The bases are 14 and 24 right here and here. So the area comes out to be 313.5 feet squared. And now we want to ask ourselves, well, how many cans will he need to purchase for 2 coats of paint? So he wants to essentially cover this twice. So because he wants 2 coats, we're going to take this number times 2. So 313.5 times 2 would equal 627 feet squared. And now we're going to take that number and divide that by each can. Each can covers 72 square feet, so let's divide by 72. That comes out to 8.7. We can't really buy 8.7 cans. We're just going to have to go up. We're going to have to buy 9 cans so that we have enough. If we bought just 8 cans, we wouldn't have enough. So 9 cans is the answer there. You had to find the area, and then you also had to think about, well, then how many cans do I need to purchase? All right, so that's it for 9.1. Go ahead and do the exit ticket and have the homework turned in as well as the notes.